What is going on, everybody? Back for another video. All right, so this one we're gonna find this limit here. It's the limit of 2x minus 3 over 2x plus 5 raised to the 2x plus 1, and we're taking the limit as x goes to infinity. So if you look at this as x goes to infinity, this part on the inside is just 1. Okay, because remember, you can drop off the 3 and the minus 3 and the 5, and you end up with 2x over 2x, which reduces to 1. And then as x goes to infinity, that exponent is going to infinity. So you got 1 raised to the infinity, which that's an indeterminate form. All right, so let's see how we work this. So we're going to let y equal 2x minus 3 over 2x plus 5, all that raised to the 2x plus 1. All right. Then we want to take the natural log of both sides. So we got natural log y equals natural log 2x minus 3 over 2x plus 5 raised to the 2x plus 1, which equals 2x plus 1 times the natural log 2x minus 3 over 2x plus 5. All right, we just brought the exponent down in front. All right. So if you look at this, I mean, just think about this. If we are taking the limit as x goes to infinity, this is infinity. This is 0, so we got infinity times 0, don't we? We can't have that. So let's just kind of rewrite this one a little bit. So this is equal to the natural log of 2x minus 3 over 2x plus 5 over 1 over 2x plus 1. I wrote it as a fraction because remember, in the end, we're taking the limit as x goes to infinity. So look at what happens here. And that's the thing that you want to keep in mind, that what am I taking the limit of? Okay, so if you look at this, if x is going to infinity, well, we just talked about how this is 1 in here because we drop off the negative 3 and drop off the 5. 2x over 2x is 1, so we got natural log of 1, which is 0. And then down here, the 1 over 2x plus 1, if x is going to infinity, this is getting really big, and that's staying at 1, so that's 0 also. So we actually have 0 over 0 once we go to take the limit. Okay. All right, so let's go ahead. Let's go ahead and do the limit of this. So we've got the limit as x goes to infinity of natural log y is equal to the limit as x goes to infinity. And I do want to show you how I get from here to here. Well, just think about this. If I divide this, remember, this is natural log 2x minus 3, the natural log of 2x minus 3 over 2x plus 5, right? Divided by this, or we can say times the reciprocal. And you can see we end up with that. So this is just another way to rewrite it. And I rewrote it like that so I could get it in the form of 0 over 0 once I take that limit. So this is going to be the natural log of 2x minus 3. Why do I keep doing that? Of 2x minus 3 over 2x plus 5 over 1 over 2x plus 1. All right, so remember, I'm taking the limit as x goes to infinity. We just talked about it. I've got 0 over 0, right? Let's just put all that in parentheses. I got 0 over 0. So I need to take the derivative of the numerator and the derivative of the denominator. Well, this part right here might be kind of nasty to take the derivative of. But what I can do here is I can rewrite it, the limit as x goes to infinity of what? Natural log 2x minus 3 minus natural log 2x plus 5, right? Division. that splits up into subtraction, and that's over. And then this one, I'm going to write that as 2x plus 1 to the negative 1. So I just took this and moved it up there. And remember, this is like raised to the first power. So when I move it up across that fraction bar there, it changes the sign of the exponent. All right, so we need the derivative of this. So that's going to be the limit as x goes to infinity of 2 over 2x minus 3 minus 2 over 2x plus 5. Remember, derivative of natural log, whatever you're taking the natural log of, that goes in the denominator, and then the derivative of that denominator goes in the numerator. And then same thing for this one. And that's over. All right, so for this one, remember the negative 1 comes down, 2x plus 1, subtract 1 from the exponent, times the derivative of what's inside the parentheses. That's just chain rule there. All right, so now I have the limit as x goes to infinity. All right, so I need to get a common denominator here. This is 2x minus 3 times 2x plus 5. And then I've got 2x minus 3 times 2x plus 5. Got a common denominator. So this is going to be 2 times 2x plus 5, 2 times 2x minus 3, over, and that's going to be, let's write this as negative 2 over 2x plus 1 squared. That's the derivative there. And so now I have the limit as x goes to infinity of 4x plus 10. Now remember, I'm distributing a negative 2, so that's minus 4x plus 6 over negative 2 over, well, let's put the negative up there with the 2, negative 2 over 2x plus 1 squared. Whoops, and I messed up. That's going to be 4x plus 10 minus 4x plus 6 all over, all over the common denominator. I'm sitting here concentrating more on making sure I get all the arithmetic correct. I forgot to bring that common denominator with me. And we can put parentheses here too to show it's the limit of all that. We'll do it up here too. Be consistent. All right, so now I've got the limit as x goes to infinity. The 4x's go out, and so that's going to be 16 over 2x minus 3 times 2x plus 5. Now I'm going to write out all the steps so you can see it. 2x plus 1 squared. All right. And so now this is going to give me the limit as x goes to infinity of 16 over 2x minus 3 times 2x plus 5 times, see, it's this divided by this, so it's this times the reciprocal, 2x plus 1 squared over negative 2, which is equal to the limit as x goes to infinity of negative 8 times 2x plus 1 squared over 2x minus 3 times 2x plus 5. All right. Now, I don't know if you can see this, but this is going to be equal to negative 8 because this is just going to be 1. Think about this. When you FOIL this out, okay, well, let's look at it like this. This is equal to negative 8 times the limit as x goes to infinity of 2x plus 1 squared over 2x minus 3 times 2x plus 5. All right, so I just pulled the negative 8 out. Remember, we can do that. And so this is just going to be 1 because when I FOIL this out, I get 4x squared plus 4x plus 1. And here, I don't even care what the rest of it is, but that leading term is 4x squared. Okay, so the 4x squared and the 4x squared, they cancel out. So that's the limit as x goes of 1 as x goes to infinity. which is just 1. All right, so now that I've explained that, I'm gonna go ahead and write it all out. I'm gonna multiply all this out and show you. And so that's -8 times the limit as x goes to infinity. Now we FOIL this out. Remember, this is 2x plus 1 times 2x plus 1. And so that's going to give me 4x squared plus 4x plus 1 over 4x squared. And that's going to be what? 10x minus 6x is 4x. And then minus 15. And so that's going to be -8 times the limit as x goes to infinity of 4x squared over 4x squared. Remember, when you're taking the limit as x goes to infinity, you got this rational function. You can just keep the largest exponent from the numerator, largest exponent from the denominator. And so this is -8 limit as x goes to infinity of 1, which is -8 times 1, which is -8. All right, so that was quite a bit of work there. Now let's just come back up here to our original problem and take that limit. So now we have the limit as x goes to infinity of 2x minus 3 over 2x plus 5 raised to the 2x plus 1. And this is just equal to the limit as x goes to infinity of y. Okay, right? Remember, I let y equal this. See? Let y equal this. So I just replace this with y. And then this is equal to the limit as x goes to infinity of e raised to the natural log y. All right, so let me explain real quick where that came from. So if you remember from algebra, we have b raised to the log of x with base b. Remember, if the base of your exponent and the base of the log are the same, then your answer is what you're taking the log of. So what do we have with e raised to the natural log y? Well, if you remember, natural log is log base e. ln, natural log, is log base e. So since the base of the exponent, the base of the log are the same, then that just equals what you're taking the log of. And that's what we did. We just rewrote y as e raised to the natural log of y. And so then we know this is e raised to the what? Well, what's the limit of natural log y as x goes to infinity? Well, see, we calculated that right here. The limit of natural log y as x goes to infinity. And see all the work we did? And we ended up with -8. And that's your answer. All right, so that was a pretty good problem there. I hope you enjoyed it. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.